welcome to my Ti-Nspire walkthrough 4. My name is Robert. Hope your day is going well. And yeah, let's get started. The agenda for today is I'm going to show how to get to the second derivative and how to find the inflection point. I'm gonna answer the following questions. What is an inflection point, anyways? What does it mean? How do we find inflection points? There are many ways. I'll show how to find them using the second derivative and Bayer graphing tools. So straight away, without getting into the problem just yet, inflection point is when the second derivative of a function changes sign, simply, when it goes from positive to negative or from negative to positive. Is at the functions level, at the like before you even take derivatives, it's when your function is changing shapes from concave up to concave down, or from concave down to concave up. The and like when you look at that through the lens of the first derivative, it can be very easy to sort of tell from at least the picture when I show this later that it's the first derivative of the first derivative. So you'll be able to see like the fastest rate of change when you have an inflection point, or maybe the slowest rate of change. And I'll show this later. It's sort of it doesn't do it I guess justice to put into just into words without drawing a picture. So and yeah, so here's our example MCQ problem. So you have the function f of x equals 2x cubed minus 10x squared plus 6x plus 5. What is the value of f prime of x at the x value of the inflection point? So first, let's see if there are inflection points in this function. And I'm going to go to my Ti-Nspire software. Okay, so this is our function 2x cubed minus 10x squared plus 6x plus 5. Just because I don't want to have to type this in every time, I'm going to press Control var to store it into a dummy variable. I'm just going to call it a. If I type in a, I immediately get that. Got our function we wrote. Now, if you go to this button next to this book, and then you see here we can get the first derivative, and then the second derivative. Well, we want to look at the second derivative, and this is a 2, not a z, in case. All right, now if we're taking with the derivative with respect to x, so we have to put x in the bottom, and to our right we want to put an a. We could retype this all out, but that just takes a lot of time. Okay, so we got that the second derivative equals 12x minus 20. Now, if we type in solve, and then put this function into the parameter, and set it equal to 0, comma x, this solves for this function when it equals 0 for the x value. If you press enter, all right, so we got x equals 1.6 recurring, which is also 5/3. You can also write it like 1 plus 2/3. Either way is fine. All right, and if we go back to our presentation. All right, so the first option we have is there are no inflection points in this function. Now, if we go back here, okay, so we want to, if we're doing the second derivative test, and we want to see values left and right of the 0 of the second derivative, go to this, if you press Control and then the equal sign, and then press this symbol means given, so it sets a value, it sort of, it takes this function and then says, okay, given this function, what do you want to calculate for? And I want to calculate for x equal to, say, 1.5, a little bit less than the 0. Okay, so we have a negative number here. It's a -2, but what's really important is just the sign. And if I do x equals to 1.7, so right of our 0, I have a positive 0.4. So, is it an inflection point? Well, yes, since it's changing sign. And if we go back to PowerPoint, yeah, so first find the second derivative. We did that. Pause here and try to find it for yourself. Try doing this on like a sheet of paper or something, and review like the different derivative rules. Find f prime of x as well. It'll be useful later. And this is the point where you should pause and try to regurgitate what I just did, but by yourself and not using the calculator, and then to double check using the calculator. And to get f prime of x, that's just as easy as using this first one, pressing A, and this is our first derivative. So this will be useful later. And if we go back to our agenda, all right, well, we already did this. Solve for x when f double prime of x equals 0. Pause and do this for yourself. Well, when we found that x equals 1 2/3, and we know that it changes sign, so option A is that there are no inflection points in this function. It's not true. So it must be C, right, because it's the same value. Well, guess again, because we're asked what the first derivative what the first derivative is at the x value, the inflection point. So, well, we know that if we plug in, well, we know that the first derivative, if we solve for the zeros, so equals 0, comma x. Okay, so we know. Oh wait, that's a little bit incorrect. If you do this and then say it's given at x equals 5 divided by 3. So this is not correct. This is a negative number. So we know it's not 0, and which means it's also minus 10 2/3. So it's D. And then that's the answer that we got here. Now, try graphing it and solve it using our Ti-Nspire. So if we go back and graph it real quick. So this is what our function looks like. And then if we take the derivative of our first function, f1 of x, and then we take the derivative of our second function, or the second derivative of our first function, f1 or f2 of x. Now, if we analyze and trace the 0 for this function, we get 1 2/3. So now all we have to do is trace, graph trace, and then if we put in what we find at 1.67, which is roughly 5/3, it's minus 10 2/3. And one thing you can do is if you take this and press command tab, sorry, I think if you press Control plus on your computer, it can, I think if you just press, if you just press the plus symbol, you'll be able to yeah, if you press the plus symbol right next to your delete key on your keyboard, you should be able to get more decimal places. And yeah, this is how you get the second the sign and the value at the first derivative. So yeah, again, through a calculator, we find that must be D. So here are some additional problems, and your answers are down here. And thank you for watching. If you have any questions or comments, please feel free to email me. And yeah. Oh, one thing I do want to comment on is that for number 2, there technically aren't any answers in terms of inflection points, but this is always negative, and it's important to know that it's always concave down. So I just want to make that clear. Anyways, thank you for watching once again, and yeah, I hope you have a wonderful day. Thank you.